Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I'm going to solve problem from NCERT, that is the chapter Thermodynamics of the Physics. So let us go one by one. So the question number 11.1. It is asking a geyser heats a water flowing at the rate of 3 liter per minute from 27 degrees Celsius to 77 degrees Celsius. If the geyser operates on the gas burner, what is the rate of the consumption of the fuel if the rate of heat consumption is 4.4 into 10 over 10 over 4? Okay. So let us draw first of all geyser. So let us consider this is a geyser, right? And in geyser, you know that there is an input as well as output. There is an input as well as output. So there is an input water system. So let us consider this is an input of water system. So further, the water will go like this and it will come through this coil at this. Okay, so this will be water in at a 27 degree Celsius and water will come out with a 77 degree Celsius. So the temperature difference is how much? 77 minus 27, so this will be 50 degrees Celsius. Okay, so this is the geyser, right? Now since this is a geyser and as per the question they are telling that the in 1 minute 3 liter 3 liter enter and exit. So the heat absorbed by the heat absorbed by water in 1 minute is equal to what? Since it is heat absorbed by water in 1 minute is how what? So we need to find mass of the water passed in 1 minute. So this is your 3 liter per minute. We can also convert it into kg. So this is 3 kg per minute. Okay. We can also convert it into grams. So this will be 3000 gram per minute. So this is the water flow rate. Okay. So the heat flow rate, heat absorbed by the water in per minute is equal to m into specific heat of the water into delta T. So mass of the water is 3000 gram passed in 1 minute and specific heat of water is 4.2 joule per gram. And the temperature difference is how much? Temperature difference is 50. So when we multiply this, so we are going to get 6.3 into 10 to the power 5 joule per minute. Okay. So this is the amount of heat absorbed per minute. And they have also given that they have also given that its heat combustion rate is how much? Heat combustion rate is equal to 4 into 0 into 10 to the power 4 joule per gram. Now we need to find rate of consumption of the fuel. So you know that there is a fuel, by the help of fuel it can heat the water. We are not using here, they are not using here the electricity. So external burner is used for heating and burner has a fuel and fuel, right? And fuel gives the heat of 4.0 into 10 to the power 4 joule per gram. Okay, so when when a fuel of 1 gram will burn, then they will give a 4 into 10 to the power 4 joule per gram. So let us now say that what is the rate of consumption of the fuel. So the rate of consumption of fuel is equal to rate of consumption of fuel is equal to rate of heat absorbed divided by heat consumption. heat consumption. So now we need to put the value. So this will be 6.3 into 10 to the power 5 joule per minute divided by 4.0 into 10 to the power 4. So finally we will get the answer as 115.75 gram per minute. So this much amount of a heat, this much amount of the fuel has been consumed per minute. So I hope you have understood this question. Now let us go for a question number. Next question number. The next question number is 11.2. In 11.2, what amount of heat must be supplied in to a 2 into 10 or minus 2 kg of the nitrogen at a room temperature to raise its temperature by 45 degrees Celsius at a constant temperature. Molecular mass of the nitrogen is 28 and R is given as 8.3 joule per mole per Kelvin. Okay. Now see here. Amount of heat supplied is this. So the mass heat supplied to this. So mass of the nitrogen gas is given as 2 into 10 to the power minus 2 kg, or we can also convert it into grams. So this will be 20 gram. Okay. Now the temperature difference. Rise in temperature is 45 degrees. So there will be temperature difference of 45 degrees Celsius. Okay. Now the molecular mass of the nitrogen is given as 28. Now can we find the number of moles? So number of moles is equal to mass by molecular mass. So mass is given as 20 gram divided by molecular mass is 28. So there you will get a number of mole as 0.714. So we have got number of moles. Now also there is given as the R as a 8.3 joule mole inverse Kelvin inverse. Okay. Now in question, what amount of heat must be supplied? So heat must be supplied. So they are asking about the heat. So heat must be supplied to raise the temperature. So Q is equal to N number of moles into Cp at a constant pressure into delta T. So this is the formula. So we have got value of N as from here. We need to find a Cp. So how you will find Cp? So the basic formula for Cp is equal to F plus 2 by 2 into R. What is F? F is degree of freedom, degree of freedom. And for since here N2 is diatomic, so degree of freedom F is equal to 5. So if we put the value of F is equal to 5, if we put the value of F is equal to 5, so how much we are getting? So degree of how much you are getting? So Cp will be equal to 5 plus 2 divided by 2 into R. R is equal to 8.3. 8.3. So finally it will be 7 by 2 into 8.3. Now we have got the Cp and delta T. Now we can find the amount of heat absorbed. So amount of heat absorbed is equal to N mole, that is equal to 0.714 into Cp value is 7 by 2 into 8.3 into delta T is equal to 45 degree. So when we multiply it, so we will definitely get approximately is equal to 933.75. So this will be approximately equal to 934 joule of heat. We can get this answer. So I hope you have understood this question. So this is the result, or this is the result. So any one of them you can write. So approximate value will be 934 joule. 934 joule approximately. Now let us do question number 3. Question number 3 is explain why two bodies at a different temperature T1 and T2 is brought in thermal contact do not necessarily settle to the mean temperature T1 plus T2. See, at first they are asking that let us consider this is a body 1 having a mass m1, having a temperature T1, and having a specific heat S1. And there is another mass having a mass m2, specific heat S2, and the temperature T2. Now when we mix it, so the T equilibrium should be T1 plus T2 by 2. Is it possible? Is it possible or not? Now, as per the conservation of the energy, conservation of energy, heat lost is equal to heat gain. So this thing we know. So if heat loss is equal to heat gain, and let us consider T1 is a high temperature and T2 is the low temperature. So heat lost by this body is how much? So this will be M mass M1 specific heat into temperature difference, that is equal to T1 minus T equilibrium, and heat gain. So heat gain by this object is how much? So the heat gain by this object is equal to M2 into S2 into temperature difference. So temperature difference will be how much? Temperature difference will be T equivalent minus T2. Now if we rearrange that, so we will get T equivalent as M1 S1 into T1 plus M2 S2 plus T2 divided by M1 S1 plus M2 S2. So we are not getting the desired result like this. Okay. So it is not necessary that we will get. So in case if M1 is equal to M2, S1 is equal to S2, then what will happen? T equivalent will be equal to, see, M1 S1 and M2 S2 all are common. So M as, let us consider all as a mass as a M and a specific heat as S. So M S T1 plus T2 divided by MS 2, so 2 MS. So MS goes cancel. So T equivalent is equal to T1 plus T2 by 2. So this is only the case. It happens only when this will happen, that is mass. Else we will always get this. Okay. So I hope you have understood. Now we can go for a next question. It is 10.4. So 10.4 B. We need to understand that a coolant is in a chemical or a nuclear plant, that is liquid used to prevent the different parts of the plant for getting too hot, should have a high specific heat. So we know that Q is, if heat is absorbed by the coolant, so this will be equal to M into S into delta T. We actually want to absorb heat in as a coolant. We as a coolant want to absorb heat from system. So the rate of heat absorption, if heat absorbing rate is high, it means it is good coolant or effective coolant. So our focus is that dq by dt should be high, and this is equal to dm by dt into s into delta t. See, mass flow rate should be constant because we don't want to increase that. We have efficient one. So if you want to increase this, so you have to increase specific heat. So if we want to increase dq by dt, then dm by dt should be increased. Okay, so I hope you have understood this question. Now, next question is that air pressure air pressure in a car tire increases during the driving. So let us create, there is a car tire, and inside this there is an air molecule. So there is an air molecules. Okay, there is an air molecule inside the car tire. Okay, so what will happen when we derive when we derive? So the air molecules speed will increase. That means, that is, kinetic energy will increase. That means temperature will increase. Okay, so we know that PV is equal to MRT. So MR is constant and T is constant. It means that PV is equal to MRT. So MR is constant. So volume is also constant. Here volume will remain constant. Volume will remain constant. Okay, constant. So if volume will remain constant, so pressure is directly proportional to temperature. So if high speed, there will be an increase in speed, so temperature will increase. So due to this, pressure will increase. Hence, high speed of air, temperature will increase, resulting pressure will also increase. So I hope you have understood this. Now there is a second part of the question. Second part of the question, they are telling that a climate of the Harvard town is more temperate than the town in a desert. So temperate means moderate climate. Moderate climate. So let us consider this is the earth and there is a two place and they have same latitude. If they have same latitude, so the same amount of sun will rays will fall. Same latitude means same latitude means same amount of same amount of rays, sun rays will fall. Now the situation is that there is one side there is a desert. So this is a desert and there is another side there is seashore. So there is a lot of water. So here no water, so high no heat, few amount of heat will be absorbed. So high temperature in daytime, high temperature in daytimes and low temperature in night. But when we talk about the seesaw, so due to water, see, due to water, it will absorb high amount of temperature, high amount of heat, high heat energy. So it will make surrounding moderate, and at night time it will release heat slowly, so making surrounding bit hot. So at night, so that's why the climate at the harbor near the sea is moderate or temperate. So I hope you have understood. This is very easy questions. Now let us consider 11.4. A cylinder with the movable piston contains 3 moles of hydrogen at a standard temperature and pressure. The walls of the cylinder are made up of a heat insulator and the piston is insulated by having a piles of the sand on it. By what factor does the pressure of the gas increase if the gas is compressed to the half of its? So let us draw the piston cylinder system. So there is a piston cylinder system. So let us consider there is a piston cylinder. This is a piston and cylinder. There is a sand outside and there is also insulated outside. So it has been insulated. So it means that no heat is going in or out. So it means that system is adiabatic. System is adiabatic. System is adiabatic. So if system is adiabatic, so that means change in heat is equal to 0. Okay. Now there is a inside there is a hydrogen, so H2 molecules gas. Okay. So it has been compressed. It is compressed. So if it is compressed, so what will happen? It is compressed. So it is compressed. So initial velocity volume is V naught. So final volume or V2 will be not by 2. Why? Because as per this, they are asked and they are telling that by what factor does the pressure of the gas increase if compressed to the half of its original volume. So there is a V naught and it is your V naught by 2. Okay. So let us consider pressure. Initial pressure is P naught. The final pressure is how much? Or initial pressure is P1. So the final pressure will be how much? That is P2 is how much? We need to find this. Since here we have understood that it is an adiabatic system. So adiabatic system P B to the power gamma is equal to constant. So we can also write P1 V1 to the power gamma is equal to constant. So we can also write here P1 V1 to the power constant is equal to P2 V2 to the power gamma constant. Now from here we want P2. So P2 will be equal to P1 into P1 by B2 to the power gamma. Okay. Now if we put the value, so what will happen? B1 has a value B naught by B2 has value B naught by 2. So put the values. So we will get P2 is equal to 2 to the power gamma into P1. Now what is the value of gamma? Gamma is equal to 1.4 for diatomic gas. Okay, diatomic gas. So since it is hydrogen, so hydrogen is a diatomic gas. So we can put here the value of gamma as a 1.4. So will be equal to 2 to the power 1.4 into P1. So finally, if you calculate it, so the result will be approximately equal to, I think 2.46. If we calculate, this will be 2.64 times initial pressure. So whatever, this is the desired result. We are expecting this result. So I hope you have understood this. So final pressure will be 2.64 times the initial pressure. So I hope you have understood this question. Now let us go to the next question. It is 11.5. So 11.5, it is given that in a changing the state of a gas adiabatically from equilibrium state A to another equilibrium state B, an amount of work done is 22.3 joule is done on the system. If the gas is taken from the state A to B via a process in which the net heat absorbed by the system is 9.35 calorie, how much is the net work done by the system in the latter case? So there are two cases, okay? So let us assume that there is a state A and there is a state B, okay? So in while going through the state A to B, so this is one of the process. So this is process one. We can also go via this process. So this is process two. If we want to draw the PV diagram, so it will be, is it like this only? So this is, let us consider A and this is B. So while going to A to B, this may be the path, this may be the path. So path may vary. Now for the condition 1, what are the data they have given? So they have given that from the condition 1, it is adiabatic. So adiabatic means what? Delta Q is equal to 0. So heat is equal to 0 for case 1. Case 1, heat is equal to 0 due to adiabatic system, due to adiabatic process, due to adiabatic process, okay? So this is your adiabatic process. Since it is your adiabatic process, so delta Q is equal to 0. So case 1, delta Q is equal to 0. It is an adiabatic process, and they have also given that delta W, work done, is equal to how much? Work done is equal to minus 22.3 joule. Why? Because it is work done on the system. So this is the case 1. So this is the case we are talking about. Now if we talk about case 2, so case 2, they have not given it is an adiabatic system or not. We don't have such a thing, but they have given the net heat absorbed by the systems. Net heat absorbed by the system, that is delta Q. So this will be equal to 9.35 calorie. Why you should keep it in a calorie? So we should convert it into joules. So 9.35 into 4.19 joule. Okay. So I hope you have got the delta Q. Now what type of equation we have? Now we have two type of equations. So case 1, delta Q is equal to delta W plus delta U. So delta Q is equal to 0. Delta W is given as minus 22.3 joule plus delta U. So from here delta U we have got as 22.35 joule. So this is first delta. Now the thing is that delta U will remain constant. Delta U will remain constant for both process. Now you may ask me that why this happens. Because it is state function. It is state function. It is state function. It does not depend on the path. So if it does not depend on the path, so delta U either it will only depends upon initial and final state. So initial and final state for the both the process are same. So that's why delta U will remain constant for both the process. So in case 2 also, case 2 delta Q, case 2, when we talk about the case 2, when we talk about the case 2 also, so in case 2, case 2, delta Q is equal to delta W plus delta U. So delta Q is equal to, they have given as 9.35 into 4.195, and this is equal to delta W plus delta U. Delta U is equal to 22.35. Now from here, case 2, delta W, we want delta 2 for the process 2 is equal to 9.35 into 4.195 minus 22.35. So when we subtract this, so our result will be approximately equal to 16.88 joule. So the final result may be, if you want to round it off, so work done for the process is equal to, by it will be by the system only, because we are getting positive value, so this will be 16.88 or 16.9 joule only. So this is the final result for which we are talking about. Okay, so now I hope you have understood this. So let us go for next question. Okay, next question is your 11.6. 11.6, two cylinder A and B of equal capacity are connected to each other via stop cock. A contains a gas at a standard temperature and pressure. B is completely evaporated. The entire system is thermally insulated. The stop cock is suddenly opened and answer the following. So the final pressure of the gas, what is the change in internal energy? So let us do step by step. Let us draw the diagram first of all. What are the condition or what are the situation? So there is a two cylinder. So let us consider this is cylinder, and it has been connected by stopcock. There is another also cylinder of the same size, okay, equal capacity, okay, and they've been connected by the stopcock, okay, is by a stopcock. A contains a gas as STP, so it contains a gas at STP. So if it is telling that STP, that is standard temperature pressure, so pressure will be equal to 1 atmospheric pressure. Now let us suppose it has volume B, so it will definitely has a volume B also, okay. Now tell me, it is thermally insulated. It is thermally insulated. If it is thermally insulated, so what will happen? If it is thermally insulated, it means that delta Q is equal to 0. Now if you remove this stop bulb, so what will happen? No physical movement is there. No piston movement is there. No physical movement is there. Okay. No physical movement is there. So if there is no physical movement, it means that the work done will be equal to 0. Okay. So work done will be equal to 0. Now as you know that delta Q is equal to delta W plus delta U. Now since both are 0, these are also 0. It means that delta U is equal to 0. It means internal energy remain constant. Internal energy remains constant. Okay. So what does it means? Internal energy IE is directly proportional to temperature. So it means that temperature will also remain constant. Now the thing is that earlier its volume was B. And finally its volume will become 2V, because when you will remove this stopcock, so the volume will become 2V. Okay, so now let us assume, let us see that PV is equal to nRT. So T is constant, so it means PV is equal to constant. So can we have P1 V1 is equal to P2 V2? So if P1 V1 is equal to P2 V2, now we can find a pressure, final pressure, that is P2. So P2 will be equal to P1 V1 by V2. Now initial volume, now let us see, initial volume was only V, but when you remove this box, so it will acquire this also, gas will acquire this volume as well as this volume. So the V1, let us consider initial volume was V, so final volume will be 2V only. So we need to put here the value. So final pressure P2 will be equal to P1 into V by 2V. So pressure P1 is 1 atmospheric pressure. This will get cancel out. So this will be 1 by 2. So this will be 0.5 atmospheric pressure. Now let us go through the step by step what they are asking. First of all, what is the final pressure of the gas in A and B? So definitely I have got the result. So the final pressure P2 is equal to how much? We have got 0.5 atmospheric pressure. Now what is the change in internal energy of the gas? So change in internal energy of the gas is 0. So delta U is equal to 0. There is no change happen. What is the change in the temperature of the gas? So temperature will remain constant. So again, no change. Now one thing they are asking, that due to the intermediate state, the system before settling final equilibrium lies on the PVT surface. Definitely not, because since it is the very fast process, since it is very fast process, very fast process, so we don't have any idea, we don't have any idea regarding what is happening at intermediate, what is happening at mid. So it does not lie on the PVT surface, it does not lie on PVT surface. So I hope you have understood this. So these are the explanation for all the questions from book A, B, C, D. Okay. Now let us go for an 11.7 question. 11.7. An electric heater supplies the heat to the system at the rate of 100 watt. If the system performs a work at the rate of 75 joule per second, at what rate is the internal energy is increasing? So let us draw the system. So let us consider this is the system, and system given to the heat. So Q in is how much? Q in is how much? So this is what? Basically they are giving the rate of heat transfer, that is dQ by dt. Also they are giving a rate of work transfer, that is dW by dt. This is how much? 75 joule per second. This will be 75 watt. Okay. Now what they are asking, they are at what rate is the internal energy is increasing? So there is a internal energy is increasing. So we know that is the first law of thermodynamics. So first law of thermodynamics is that delta Q is equal to, or we can also write like this, Q is equal to W plus delta U. So if we divide it by all, by delta T only, delta T, so we are getting dQ by dt is equal to dW by dt. plus d change in internal energy, rate of change of internal energy. We require this only. We require this only. Okay. So dq by dt is how much? Dq by dt is given as 100 watt. So this is 100 watt only. So this is your 100 watt, right? So we have got dq by dt as a 100 watt. 100 watt, okay. And dw by dt is how much? 75 watt. We want du by dt, that is rate of change in a internal energy. Rate of change of internal energy we are getting as 100 minus 75. This will be only 25 watt. So I hope this is the result what we are thinking of, dw by dt. So this is our result. Okay. So I hope you have understood this. Now let us go for question number 11.8. 11.8. A thermodynamic system taken from an original state to an intermediate state by a linear process shown in a figure. Okay. Its volume is then reduced to a original value from E to F by an isobaric process. Calculate the total work done by the gas from D to E and E to F. So when it system undergoes from D to E, E to F, so what happens? We need to find the net work done. So as we know that, know that yeah, under EV curve gives you work done. Work done. So work done here, work done is equal to area of triangle DEF. We can find like this. So area of triangle, that is equal to half into base. Base is how much? FE. FE is how 5 minus 2 into EF. EF is how much? Sorry, DF. DF is how much? DF is 600 minus 300. 600 minus 300. So we will get the area. So we are getting half into 3 into 300. So this will be 450 joule. So the work done in moving from D to E, E to F is 450 joule. So this is very simple example. So whenever you want to find the work done, don't go for step by step. Just you find the area under area the whole cycle. Okay. Let us suppose that if it is your pressure and volume and there is a line like this. If you want to find a work done between A and B, so you have to find the area under this curve. Since it is closed cycle, so that's why I am finding the cyclic work done. Okay. So hence you can find this way. So this is the easier process. I hope you have enjoyed the lesson, and thank you very much for watching the video. Okay.